Top of the morning to you viewers, Mike here. There's going to come a time when you're using an index head and you have to be able to pick up something on a radial position. And we have no way of knowing at this point, other than eyeball, of where the bottom of this Woodruff keyway is. And we want to get it set exactly on center so that when we come down with our keyway cutter, that the bottom edge of our keyway cutter is exactly in line with the one edge of the keyway. Because when we welded this, we purposely left a little bit of witness on the one side of the keyway. This one side wasn't damaged, so we left a witness on that one side as a reference so that we could pick that up. Okay, now this is a good use of my planer gauge. What we do is, first of all, we pick up the top of our shaft in a similar way that we set our cutter. Then we set a 0 on our planer gauge. And the way I set a planer gauge is I get my thumb right underneath the movable jaw and I just kind of put pressure on it, slide it up until I get a 0. Okay, now we've got a 0. And what I do is when I'm using an indicator, always check for repeatability. There's a 0. Now, looks like we're off 2,000ths there. So back over here we go, too high, slide that down to 0. And check repeatability, 0, 0. Okay, so now what we do is we take our micrometer and get a reading on our planer gauge across here. Then we take that distance, that half the shaft diameter plus half the width of the keyway, we take that distance and we subtract it from our planer gauge and we get a new setting. Okay, I'm going to simulate that. Let's say now we get a new setting here. Over here, set our indicator to 0. I do have a little cosine error there. That's okay. And we come over here to our keyway. And we turn our index head until we come up and we get 0. Check our repeatability, 0. Okay, we lock in the radial position of our index head, and now our keyway is set exactly, the center of the keyway is set exactly on the center of our shaft. Now when we recut our keyway, we set the top of the keyway cutter on the top, down half the radius, or half the diameter, which is the radius, plus half the width of the keyway, and then our keyway cutter will exactly touch the one side of the keyway that's already in there. Now the sad story on this one is I welded this shaft, or welded this keyway up, and I knew the risks, but I thought if I cooled this thing nice and slow that it wouldn't go hard on me. Well, I already tried to cut this with a keyway cutter and that's so hard I can't cut it. I have two options now. I can take this weld back out of here and put silicon bronze in there, or I can send it out and have it normalized. I really hate to heat and cool this shaft any more times than I have to. It's already been welded once. Have to save the shaft somehow. It's irreplaceable. So that's it in a nutshell. I hope you got something out of this. We start out doing a little hogging here to get rid of this excess material. We're turning over 560 RPMs with an 8 thousandths per revolutionary crossfeed, and we've got a depth of cut of 100 thousandths. And this is a W style insert. And suddenly I'm getting spaghetti chips. The thing about spaghetti chips is they lodge in the hose of your shop vac, and that's a real job getting them out of there. Okay, viewers, now we've got the pinion turned up. The lathe work is done, so we have to cut the teeth into this, and we have to cut a Woodruff key way into it, which will go right here, and then we have a cross hole to drill, and we'll do that last because we want to go right exactly between two teeth. So, okay, that'll conclude this one, and we'll see you next time.